Good afternoon. It is science time once again. Today we're picking up with Chapter 2, Lesson 4, Deaths Changing in a Population. So, in order for today's lesson, you'll need to access our notes for today. You can find those on Google Classroom. You'll be recording. These are your notes, always in the Word format. You can follow along. That'll keep pace with the lesson. And then your recorded answers need to be placed in the Google Form document, Deaths in a Changing Population Guided Notes. That's where you'll be recording your answers to the questions that are found in your daily packet. So let's get started. So you've learned about how the number of births can change in a population, but we're not sure that the births in the jelly population did increase. A decrease in deaths could also have led to an increase in the size of the jelly population. Today, you will investigate what can cause the number of deaths in a population to change. So, for your PDN, you'll record your answers on the Google form. Here is your posed question. Foxes eat small animals called voles. In southern Sweden, scientists observed that when the vole population decreased, the fox population also decreased. Explain why the fox population decreased when the vole population decreased. Be sure to talk about births and deaths in your answer. Go ahead and pause this video and record your answer in Google Documents. So, to answer your question, foxes need to release energy in order to survive and reproduce. Foxes get energy storage molecules from eating voles, and they can use those molecules to release energy. If there are fewer voles, then there are fewer energy storage molecules available to the foxes. If there are fewer voles, and therefore fewer energy storage molecules, then the foxes will not reproduce as much. If there are fewer births and deaths, the population will decrease. Today's aim. Kipsters will construct explanations about how the size of a consumer population affects the number of deaths in a resource population. Changing the number of deaths in a population. What can change the number of deaths in a population? Use the sim to find out. In the sim, furbles eat wee bugs, and wee bugs eat green leaves. What changes would decrease in the number of deaths in the wee bug population? Check all answers that you think are correct. Do so now on your Google form. So, what do you think would cause a decrease in the number of wee bug deaths? Well, since we know that furbles eat wee bugs for energy, then furbles are the predator, wee bugs are the prey. Furbles being a consumer population and wee bugs being a resource population. So one way that we could decrease the number of deaths in the wee bug population would be to decrease the number of furbles. The less furbles that are present, the less wee bugs would be killed by furbles. So, for today's activity, for part 1, we are going to conduct a quick experiment. We're going to change the independent variable in our simulation And in this case, that independent variable will be that independent variable that we will change will be the number of furbles. So the less furbles that exist, the less wee bugs will be eaten and die. Our dependent variable will be the number of wee bug deaths. So we're going to guess that the number of wee bug deaths is tied directly to the number of furbles present. And the control group that we'll use will be the number of green leaves. We'll leave that number alone. So the only thing that will be changing is the number of predators, and we will see what the effect of that is on wee bug deaths. It's important to remember that you make large changes in order to see large effects. So on our simulator, we're not going to only take away 1 or 2 furbles. We're going to remove probably the majority of them to be able to see the largest effect. Once we do that, we'll lock that population so that way the results can be seen more easily, and we'll record our differences. First, letting nature take its course as normal for about 20 units of time, and then we'll make our changes, lock that population, and observe the effects of our change. So we're going to head to our simulator now. So folks, on our tracking sheet, we are going to take a look at, we've already filled out our information on our Google document. And what we're going to do is run our test. So the first test we'll run will be as follows. So here we are back on our simulator page. What we're going to do first is let the population run its happy course for about 20 seconds, and then we'll observe the number of wee bug deaths in a standard unaltered scenario. So let's let it run. I'm going to let 20 time units pass. All right, so that time is passed now. What we're going to do is analyze the number of furble deaths. Sorry, the number of wee bug deaths. So when we take a look at our tracker, you will notice that over here on the wee bug population, in that amount of time, we had 22 wee bugs that were dead or that died for whatever cause. So when we go to our tracking system, the thing that we were going to do that was going to decrease the number of deaths in the wee bug population was decrease furbles. We do so because furbles are predators and a consumer population. They gain their energy storage molecules from the wee bug population, which is a resource population. If we decrease the number of furbles, then the number of wee bug deaths should decrease. What we're going to change will be, once again, the number of furbles. What we will observe and record will be the number of wee bug deaths. And what we'll keep the same will be the number of green leaves. So what we're going to record on our data table will be our findings. So the first thing we should record will be our regular data that we just found. So without altering any information, we have the following numbers. We had 22 wee bugs that died. Next, we're going to change the simulation where we are going to decrease the population of furbals. And we're going to do so dramatically. The starting population of furbals was about 32. It's held fairly steady across time. So now when we go back to our simulator, we are going to actually change that population. So we're going to dramatically decrease the furbal population and lock that population. Then we're going to allow the simulation to run for another 20 seconds. There we are. So let's analyze our new data. So we can see that when we dramatically reduced the furbal population, our wee bug population, overall deaths in that same 20-second or 20-unit measure of time, went down to 20. So, what changes decreased the number of deaths in the wee bug population? Decreasing furbals. After this change, the wee bug population increased because there were more births than deaths in the wee bug population. Now, for part 2, we are going to do the opposite. We are going to let the sim run for 20 time units, press pause, and we're going to record the number of wee bug deaths. Then we're going to reset and increase the furbal population. We'll do it again for 20 more time units, and then analyze the number of wee bug deaths. So we'll let this time run for 20 seconds. We'll analyze the number of wee bug deaths, and we had about 24. So we'll record our findings. And here we're going to increase the number of furbals drastically. So So let's go back to our simulator. Reset it. Pause. And here we're going to dramatically increase the number of furbles. We're going from about 35, we'll double it and go to about 70. So let's take a look and see what happens. Again, we'll let the clock run for about 20 time units. And then we'll analyze our findings. So when we look at this data, you can see that the wee bug deaths have jumped. They've gone up to 44. So we kind of scroll down a little bit. Given the results, what changes would increase the number of deaths in a wee bug population? Well, if we increase furbles, we definitely know that the deaths in that wee bug population would go up. However, what if we were to decrease the wee bug population's food supply? Would that also increase the number of deaths of greenleafs? Let's try that. So we know that in a 20-second time frame, on average, the wee bugs die at a rate of about 22. So this time, we're going to leave the furble population alone, but we're going to change the greenleaf population. We'll dramatically cut that down. We're going to cut it down to about half. And then we'll lock it. And let's see what happens. We'll let it run for about 20 time units. And we'll analyze our results. So here, you can see that we've had, you can see that we've had 28 deaths in the wee bug population. So we definitely increased the average number of deaths when we limited the food supply. So we could also use the information that decreasing green leaves would also increase the number of deaths in a wee bug population. The reason why these two would have effects is when we decrease the resource population that feeds the wee bugs, that directly affects the wee bug deaths. When we increase the consumer population that feeds on the wee bugs, that directly affects the wee bug deaths increasing as well. So let's go back to our notes. And at this time, you can definitely fill in the following information. So, what changes decrease the number of deaths in the wee bug population? Well, from our tests, we noticed that decreasing the furball population decreased the number of deaths in the wee bug population. After changing the wee bug population, after the change, the wee bug population increased because there were more births than deaths in the wee bug population. Given our results from above, what changes would increase the number of deaths in the wee bug population? Well, definitely when we increase the number of furbals and decrease the number of green leaves. And we already explained on the screen, on our Amplify screen, exactly what that, why that is. When we decrease the resource population that feeds wee bugs, that directly affects the wee bug deaths. It causes them to increase. When we increase the consumer population that feeds on the wee bugs, that directly affects the wee bug deaths increasing as well. Now, you have a little bit of a challenge in front of you. You need to read this discussing changes to ecosystems and record your responses on the Google form. This will be your independent practice. I'll review it later today. And then finally, our closing thought, our key concept for today's lesson. The larger the resource population, the more energy storage molecules are available for its consumer population. Therefore, it will eat more, causing more deaths in the resource population. Thanks again for tuning in today. Feel free to rewatch, rewind, and fill your Google Forms out completely. If you have any questions, please message me through Google Classroom, and I will see you tomorrow.